Hello, I'm Kira Waddell, a third-year general biology student at Red Deer Polytechnic, and Dr. Sally Stewart was my Biology 399 instructor who I did this research with. This presentation will be on acoustic monitoring of bat vocalizations in Red Deer in the vicinity of the proposed North Highway connector. So some background information on this project. I took this over from a former teammate of mine, Kelly Heineman, and since then Sally and I have been collecting data for the past 2 years during the months of May to September in the North Highway connector area. So here the area has been cleared for a connector highway, and a big reason that this piqued our interests was to gain insight into the bat population prior to the highway's construction. Looking at Figure 2, you can see that this highway runs directly through the wildlife corridor connecting the Riverbend area to the city of Red Deer. The bats are a very important ecosystem indicator and directly reflect the success of the environment, so understanding and monitoring their populations during a potentially disruptive environmental transition is very important and can tell us more about the overall ecosystem. So white nose syndrome is another reason why having a strong understanding of our bat population is very important. The fungus has recently been discovered in Saskatchewan, so it's only a matter of time until it reaches Alberta. As you can see in Figure 3, white nose syndrome is present in a lot of North America, especially through the United States moving towards Alberta. This will likely be devastating to our bat populations, as previously across North America the fungus has caused massive declines in bat populations. So the recording site was the North Highway connector on the northeast side of Red Deer, where the recorder is marked with the blue pin that you can see in Figure 6. It was right next to a wildlife tunnel as well as a forest and the river, so it was suitable bat habitat. To record the data, we used the Wildlife Acoustic Song Meter SM4 ultrasonic recorder pictured in Figure 5 with a U1 microphone. The recorder was in an open and uncluttered area to maximize its ability to pick up the echolocation calls. We collected the data chip and checked the recording device battery around every 2 weeks through the months of May to September. The data collected was then analyzed using Kaleidoscope Pro analysis software, which identifies the bat calls recorded, and then I further analyzed and visually displayed it in graphs using the statistical tool R as well as Excel. So these bats are the most common bats in Alberta. From their scientific names, there is a 4-letter code that is used to identify them. This code will be used throughout the presentation. There are also other bat species in Alberta, but they are less common. So echolocation calls are what we were recording. Bats emit these sound waves that then bounce off objects such as insects, as seen in Figure 7. The bats release these sonar waves, which when they contact an insect, they return sound waves, which can then be utilized by the bat. They're primarily used for navigation and hunting. Bats do have different types of calls for different situations, such as social calls and hunting calls. So some background on sonograms. Sonograms are a picture of sound. The horizontal axis in Figure 7 gives us the milliseconds, and the vertical axis gives us the frequency. So Figure 7 is one of the sonograms from a little brown bat call, and it's been slowed down so we're able to see the characteristic shapes of the call. Without slowing it down, the sonogram would look like pictured in Figure 8, which is really hard to categorize just by looking at. So for frequency, humans can hear up to around 20 kilohertz, but a majority of the sound we hear is around 2 kilohertz. So normally we cannot hear bat calls. This clip is a bat call lowered to a frequency that we can hear. So it's not the best sound, and it's kind of a nice thing that we can't hear bats all the time. Classifying bat calls is an extremely difficult process, and often the results cannot be replicated even by trained professionals. So looking at these images here, these are slowed down bat calls, which are identified using the Kaleidoscope software, and by looking at the shape, duration, and frequency of the call, it was able to analyze what species of bat made the call. Looking at the hoary bat, which is LACI, and the big brown bat, EPFU, you can see just how similar their calls are. They both have a similar duration of call, which is shown in Figure 10, which was collected from our 2021 data summary set. The frequency of their calls is around 30 to 20 kilohertz, starting high and tapering down, with the majority of the call being around the 25 kilohertz zone. These calls are extremely similar, and therefore we have a difficult time telling them apart. We have a similar instance with the little brown bat and the eastern red bats. The eastern red bats are not a species generally found in central Alberta, but their call is extremely similar to the little brown bats, so whether or not this species is in the area or if it's a misclassification by the program would require further research and different techniques such as capturing the bats to look at the physical differences. So with the data collected, we were able to gain useful information that allowed us to see some patterns of species, such as duration of calls, the frequency of calls, and as shown in these charts, the hourly number of calls categorized by species. So these charts are from 2020 and 2021, and they are color-coded by bat species. Along the x-axis, we have the hours of the day, and the y-axis is the number of calls per hour. This allows us to visualize popular feeding times of species and compare to what is already known about the habits and peak activity times of these species. So these graphs give us a comparison of the bat populations in 2020 and 2021. Just note that the scale on the y-axis are different. The data used from this is the number of calls recorded. So the assumption being made is that more calls equals more bats. It does not completely reflect the population, as the software cannot distinguish bats as it only counts calls. Our bat populations in 2021 compared to 2020 have increased for some species, with the little brown bat, which is the blue column there, MYLU populations doubling. The eastern red bats, LABO, and hoary bat, LACI populations also increasing. Silver-haired bats, LANO, and other Myotis species remained relatively similar. As for the big brown bats, which are the EPFU seen in the red column, these are the only species that experienced a decline in reported population over the year. So these populations are influenced by many different factors, including weather, resources such as food and habitat, and their migratory and/or hibernation patterns in the winter, which is something that we actually don't know much about. Considering all these factors, this data gives us a good idea of the general bat community in this area. So to wrap up, the data collected in this project has given us good insight into the bat populations in the North Highway Connector area and can be a useful tool moving forward as the highway continues to be developed and as white nose syndrome possibly moves into Alberta and affects our bat populations. Thank you, and I also wanted to thank everybody involved in this project, including Esther Stewart for her help with the coding for the graphs in our program, Ken Lehman from the City of Red Deer, who invited us to participate in monitoring around the proposed new highway, and of course Dr. Sally Stewart for taking me on as a 399 student and doing this research with me.